Hello, brothers and sisters. I hope you have enjoyed the last sessions. So today we are going to talk about how could we monitor the environmental temperature and humidity by using digital temperature and the humidity sensor. So the sensor we're talking about is this. It is called the DHT22. So if you can see clearly, this sensor contains 3 pins, and one pin is plus for powering with high voltage, and the other pin at the left side is the minus for connecting to the ground. So we are going to use microcontroller called NodeMCU. This is a Arduino type of microcontroller that can be connected on the internet. So we are going to use connecting wires. These are called female cables that will help us to interface our sensor with NodeMCU, which is a microcontroller. Then we have a USB cable that we are going to use to connect our microcontroller board with a computer for allowing our PC to write the code and upload the code to the microcontroller. So simply when you say that is a sensor is an electronic device then that can capture any change in environment temperature or any physical change in environment and convert it into electrical signal that can be monitored and measured by a microcontroller device. So let's jump in. First thing we are going to do, we are going to first to open the software that we are going to use. The software is called the Arduino Ide. It is an open source. You can get it wherever on the Google. It is a free. You can download it. So first thing that we are going to do is to write code. So before writing code, let me first connect the microcontroller with the sensor. First of all, I will connect with power pin. This is VCC to the microcontroller pin at the pin number 8. So for me, I pick pin number 8, but for you can choose any pin, it can work. So here my controller is connected with sensor. I connect the power pin to VCC to 3 volts. Then I connect the ground or minus pin to ground of the board. Then lastly, I connect the data pin of the sensor. We connect the data pin of the sensor to the pin number 8. Then lastly, I connect microcontroller board to my computer by using a mini USB cable. So now the connection is done. More information about circuit connection, you can go into Google and you can type ESP266. Yes, you pick is one Wi-Fi module and DHT22. That I'm using DHT22, then set the image. Then you can pick any circuit. Me pick this. Then you can visit the website for having more information about the connection. We have two types of DHT. We have DHT22 and DHT11. The DHT sensor, the blue one is the 11. It contains 4 pins, so you can check on the datasheet of the sensor. You can get 3 pins to be connected, plus, minus, and data pin, and the 1 pin is not connected. So when you're having the DHT22 as the one I'm using, you are going to make the connection like this. This is circuit that I'm using. I connected to the power pin to 3 volts of the microcontroller board. I connected the ground pin or minus pin of the sensor to the ground of the microcontroller. Then lastly, I connected the data pin to the pin number 8 of the board. So here you can put the resistors for protection of the board, but even if it is not included, it's gonna work. There is no problem. So that's the circuit. So now let me go and try to write the. So first thing we're gonna do, we're gonna first call the library of DHT. So if it is your first use the DHT sensor, you have to install the DHT sensor master library. I will show you how to install it. Then you can define where the sensor is connected. For me, I have connected to pin number 8, this of D8. Then I have to define the type of my DHT sensor. So the type that I'm using is a DHT22. Then I have to declare the DHT instance as a DHT with a small letter. Then I provide the DHT pin and indicate my sensor is connected to the pin number 8 of the board. And the type of the sensor is a DHT22. Then I start the void setup. So void setup is one of the Arduino function which cannot miss in any program. So most you use the void setup for trying to initialize the hardware and even for executing or for declaring the code that has to be executed once. So first I'm going to indicate that the serial monitor or the communication between my computer and the microcontroller board will be 9600 bits per second. So these are called a baud rate, or a number of bits to be transmitted between microcontroller and microcomputer in serial. Then I have to initialize the DHT. I have to initialize my DHT sensor. If you forget to initialize the sensor, it will not work. So I end up by declaring by defining the very setup function. So I have another function called loop. So with a loop function, any code you put within or inside the void loop, it's gonna be executed endlessly. So normally we put the code that has to be checked and executed every time by the microcontroller board. So let's first declare a variable as a float temp for reading the temperature from the microcontroller. Then define DHT.read temperature. It's an only function. Here I say I'm reading the temperature from the DHT sensor, and I store the temperature into a variable called temp. Secondly, I read the variable, I read the humidity from the sensor. Then I have to store this humidity value into a variable called hum. Then the next thing I'm gonna do, I'm going to display the readings on the serial monitor of my computer. So I will use a function called serial.print. First I print a message that says temperature. So this is a message which is gonna be printed on the serial monitor. Whatever content you put within the quotation is a string, is gonna be displayed as it is. Then the next thing, I have now to print the value of the temperature by printing the content of the variable temp. Remember, the variable temp contains the value of the temperature read from the sensor. The next thing, I will print the message that says I'm gonna next print the humidity from my environment. So I can put here the space because I want to put the space between the temperature and the humidity. I don't want to confuse you. Then I say humidity. So again, this is a string. You can replace humidity by even your own words. Then you print the value you have read. But we add LN because at the end of the printing the value of humidity, we want to move to the next line. If you go to put LN, the content are going to be printed on the same line, which is not good, it is not readable. So don't forget to put here LN for moving to the next line. Then you print this. Remember every time to put semicolon at the end of each statement, then you have to include what amount of delay or millisecond that has to be. This is the duration between the reading values or intervals, reading intervals. And then, so now the program is completed and I have connected the circuit diagram to my computer. So the next thing that I'm gonna do is to upload the code to my computer. When uploading to the microcontroller, first thing it's gonna check if there is error. And I have to select here, I have to save my code. Let me select AI and the IoT online. I save it. Now the code is being compiled. When the program is being compiled, it means it is checking, the system is checking if there is no syntax error. You have to wait takes time. The other thing you have to check if the ports were connected. So now for me, first I check the board. It is NodeMCU. It's okay. You check the port. I have port 12. Okay. If it doesn't work, you can move from the port 12 to port COM3. It depends on your computer and your hardware. The name of this port can be changed. So it is failing. We have to check again the board that I'm connecting. I select ESP, we select this, then I select it again, the port 12. Okay, it's okay. I can select it. Then I upload it again. Okay, now the code is being uploaded. Let's wait a little bit. Okay, now the code is uploaded. So the next thing we are going to do, at the right side top, there is a serial monitor. Just you click there. Then, so here the first thing that you have to do is to check if the baud rate you have declared in your code here is the same like the port that you are accessing. First thing you have to do, you have to change the baud rates. So let's look at the temperature and the humidity from environment. This means you have 26.4 degrees Celsius and you have 78 as relative humidity. Guys, this is the end of the session. Please, if you have any question, please reach out to me via my email. Even you can put a comment, I can read it and I can give you the answer. If you think there's more thing I can do for improving our lecture, let me know. Thank you. See you next time.